Good morning. The problem always being the guy who presents after the astronaut and just before lunch. I figured this is going to be a tough slot to fill. Also, I have to admit somewhat that I'm a little nervous. And normally, as some of you who know me, I always present and I never really get nervous. In fact, I'm usually writing my presentation like literally minutes before I give it. In this case, due to the diligence of the staff at Safe Software, I had to have it done much earlier than that. This is a chance to talk about something that I really like, that I don't consider myself an expert in. And so that always, you tend to put yourself out there. But that's the great thing about FME when you think about it, is it always forces you to learn something new. And even when you think you knew everything there was to know about a particular transformer, when you start playing with it, you learn something new. And so I'm going to stick my neck out and show some very simple workbenches, but here are the things that I discovered. And I hope that you'll be able to take away something from that. My main job is as a GIS technologist. So I help run projects from the technical side, and I help mentor other people. And one of my job focuses this year was to implement FME as one of our tools of choice within our organization. And I'm really pleased that there's 4 people within our group that have picked up and started learning FME. And nothing pleases me more when I walk by and I see on a double monitor this monolithically awesome workbench. And then they'll come in and say, have you ever done this? And I'm like, nope, but we can figure it out. So my job is really, and to use FME, we use it to integrate, tie things to the GIS, bring information from other systems into the GIS so that people can use them. So my job really revolves around pipeline data management. And this is really challenging because where most maps are squares. When you look at a city map, it shows up on a city square. But pipelines, they stretch for hundreds, if not thousands of kilometers or miles in any direction. So it's really difficult to work with the data, especially since most of the data, with most of the data models, use a form of location that isn't just coordinate, but it's linear referencing. It's based on the cumulative distance along a pipeline from the start of the pipeline. Obviously, understanding where pipelines are is really important because they transport very dangerous material. And there's a lot in the newspaper about these pipelines, and really my job is we need what is transported by the pipelines, but we need to be able to do it as safe as manner as possible. There's challenges that this data crosses over multiple jurisdictions. There's challenges that the pipeline operators are put in assets into the ground that are slowly being encroached upon by human civilization, right? Lots of the stories of incidents have happened because buildings and structures have encroached upon those pipeline systems. The problem also is that Mother Nature doesn't sleep, okay? Rust doesn't sleep, okay? Mother Nature really abhors when we build something and put it into the ground. I mean, if you want to go that metaphysical, you can, but really, in actuality, the pipeline system, once it's in the ground, is constantly under attack. All right, so it requires constant vigilance and assessment. And a lot of this infrastructure has been in the ground for a while. It needs to be updated, and the regulations are driving the pipeline operators to adhere to it. Our goal is really to safely operate these pipelines. We don't want incidences. Operators don't want incidences for a bunch of reasons. All right, and the more, despite of whatever the political winds are blowing, the more incidents that happen, you know, the whole social license to operate becomes a big factor for pipeline companies. And you know, we're all aware of the protests around the DAPL pipeline in the US. And people are, when they hear about it, it's instantly out on social media. So the best pipeline is the one you don't hear about, right? Because it delivers its product. And knowing the location of a pipeline is really critical, and its proximity to other geographic phenomena is really important. And if you're wondering why I'm starting off with this, because it's the context for the whole presentation. Yes, we will get into workbenches, and yes, we will talk JSON, and yes, we will talk APIs, but there's a very important reason why we're doing what we do. When you look at the risk on a pipeline, it can be distilled, and it's obviously much more complex than this simple math, but it can be distilled. Risk is equal to the likelihood of an event happening times the consequence of that event happening, in simple terms, okay? Likelihood is determined by the presence or absence of threats, okay? External corrosion is a threat. Keep pouring water on bare steel, it's going to rust. You have an elevation where your pipeline goes down and it accumulates liquid, it will rust at that spot. And you should be able to look at that and think immediately, wow, that's all about geography, right? And obviously, a consequence of an incident is hugely geographic, all right? And that could be whether or not it's loss of reputation, environmental damage, cost, loss of life, or anything like that. So we want to enable the people working in a pipeline company. Who was here in the last presentation? Who was here in the last presentation? Right, what did they say? We're short on staff, right? This is becoming a phenomenon in a pipeline company. You want to be able to get as much information as you can to your staff members so they can all help lower the risk profile for a pipeline. The more they know, the better they can make decisions about how to manage and operate the pipeline. All right, so when you take that as one of your purposes, why are we doing this and how do we do this? Getting information out to people is really, really important. And getting it out in a way that they can consume it easily is important, right? So having data about the pipeline at your fingertips, safely and easily, promotes understanding, safe operations, and allows for mitigation and remediation planning, because that is always ongoing. So look at the risk of a pipeline system. It is inherently geographic. If you go on a pipeline system on a map and click on any point, you should understand where are my threats and what are my consequences. We need to be able to give that information to the people who are operating the pipeline. The other thing about a pipeline is we think GIS, okay? And a lot of people just immediately gravitate to perhaps you're an ESRI shop and that's the geodatabase. I think that it is the entire enterprise. How do I get information out to the entire enterprise so it's at their fingertips? And that's through integration. That's through common keys, or that's through common geographic coordinates, okay? And you need to pull that information and make it available to people. So the solution to this is, and I'm not going to spend a huge amount of time talking about this, but it's a web-based portal that we have developed at TRC, which we call Integra Link, all right, and FME. So this is Integra Link. It's a quick snapshot. You can see it uses the Google Maps API. And the beauty of it is it's dead easy to use. Anybody can go into this and see all of their geographic information. But the real power of it is they can go up to this search box in the upper left and type a term. Or they can click on the map, and all of the data associated to that point will be displayed in really easy to read format. And that, the simplest part of that is it doesn't need any knowledge of what layer the data belongs to. I've been involved with pipeline data models, and the most frustrating thing is somebody comes up and say, can you teach me pods? Or can you teach me APDM? And the problem is that if you go to, it's a problem of terminology. They're always stored in tables. So what we've done in Integra Link is reduce the need to know where to get the data. You just type in a keyword that's really familiar to you, and the information is provided. Not too unsimilar from Google. Right? You have a question and you don't know the answer, where do you start? You either bug the person in the cube next to you, or you go to Google and type in a question and see what comes up. Well, this is based on the same principle. So currently, most of our clients are working in their system of record, doing their editing in QA/QC, and it's typically done in an ESRI geodatabase using SDE or ArcGIS server or whatever it's called now. All right, and then we go through some manual process to publish it to Integra Link, all right? And this is an application that works on the desktop. And I thought, you know, there's got to be a way to automate this. The details of Integra Link that I'm going to share, and I'm being very deliberate about this, is Integra Link is spooled out on Amazon Web Servers, EC2. It uses PostGIS as a background. It uses GeoServer to send out the web mapping services. I do believe it's written in Python using the Django framework, but that's it. That's all I'm going to say about it. How they manage it, I don't know, and that's the purpose of the presentation, because what they did was, instead of doing a manual process to go from the geodatabase to Integra Link, we're going to give you a set of APIs, okay? And now I'm going to use FME to talk to those APIs, to take that data in the geodatabase and put it up there so that our people can get access to their data, use it, and make decisions about their pipeline. So I commonly refer to FME like the onion, all right? Sometimes it will make you cry, especially if you like trying to wade your way through the documentation or trying to get a transformer that you should think works the way it works. Sometimes it makes you laugh, especially when you get a workbench to work, all right? And the fact that it is so geographically based, it's awesome. It's good for you, just like an onion, lots of vitamin C, all right? Because it forces you to think and discover and organize your data and how you process the data. And you may think like, well, that's completely obvious. But really, when you're sitting down and showing somebody how you do your work, being able to pull up an FME workbench, right, is pretty awesome because you can say, watch what happens and look at the numbers, how this goes. Well, what's this thing doing? I have never met anybody who doesn't get immediately interested in it. But the best thing about it is it forces you to look at your source data and say, how do I collect that information and how am I going to recombine it and do the ETL process and load it into this new system, all right? And just like an onion, just when you think you figured it out, there's another layer that you pull back. And there's, you know, and that's pretty interesting, right? Because people master software, which is great. Good, there's no FME master, in my opinion, because they're coming out with transformers faster than we can master them, and there's so many layers of complexity. And they've done a good job of, here's the simple interface, and here's, if you want to hurt your brain cells, the deeper diver interface is part of it. So on the left side, I have Integra Link, and they give me 5 API calls. 5, that's Canadian 5. 5 API calls, okay? And how it receives the API call is through Geo JSON, or just JSON, which Geo JSON is part of it. So that's JavaScript object notation. The simplest way to describe it is it's the best way to translate information in JavaScript applications, web-based applications. So Integra Link gives me 5 really simple APIs that I can call. And then what I do is I pull my data out of a variety of databases and use the JSON templater and JSON formatter. Mark Stokes is someone who I work a lot with at SAFE. I'll arrange, you know, every couple months and say, hey, I have a whole bunch of hard questions. And the one was, I had to, you know, I've got a rule with FME, right? If my workflow looks convoluted, I'm doing something wrong. If I'm like reusing a bunch of different transformers, I probably can optimize it. And if I have to lean on Python, I'm missing something. Really don't want, like I love Python, don't get me wrong, it's awesome. But when I'm doing an FME workbench, I want to do an FME workbench and make it do what it's supposed to do. And he told me about the JSON templater. I almost cried because it was like, oh, this is awesome. Like how many people here who have actually opened a JSON file? Anyone? All right, it's tough. So what I'm going to do is I'm just going to quickly toggle over here. This is JSON right here, okay? And it's nicely organized, okay? And you can see that it makes sense and it's got name and value pairs and arrays and all that great stuff, right? Now, you need a tool like this to take one long line of JSON and scrunch it so you can view it hierarchically, right? But it's very, very flexible because it's really, I'm structuring unstructured data. Okay, I'm making it in a way that makes sense. And the killer part of this is there's Geo JSON, which is a format for describing geographic features. Right? Let's see if I can go back to my presentation. All right, so the high-level workflow, and each one of these represents a workbench. I'm going to create a data set in Integra Link. I'm going to make sure that it has no data in it. We just do that as a formality because it cleans things up. Okay, not only data, but it cleans up any latency, because we're trashing data sets all the time and rebuilding them. And then I merge my data from my variety of sources, and you see that the green is really a process. The dynamic part comes whenever somebody compresses to default. Okay, we've got a little watchdog Python app that gets that message, and it launches all of the yellow workflows. So whenever somebody compresses to default, we just literally rip and replace the data out for that particular data table or data layer. So if I was tracking pipes, I would have this workflow for pipes, and I have a specific workbench set up for those particular things. Now, it seems like there's a lot of workbenches, but the nice thing about it is once we track the deltas in the version and we know something's been compressed to default, we can execute the workbenches, and they do this whole thing. So creating a data set is putting a table up into Integra Link, but creating a layer is actually visualizing it on the map. Okay, so we do have layers, but we can make those layers whatever we want using terms that make sense to pipeline engineers. So this is the merged data. It's very, very simple. The idea behind this is take a polyline representing my pipeline routes, link it with a table that describes the pipeline information with feature merger, and then add a few attributes just for auditing and tracking state. And this is the same thing but from a shapefile. And we could add it from a Excel spreadsheet. The idea is that it all ends up in JSON. Okay, it all ends up converted and written out as JSON. Okay. The next one is the create rows. Okay, and this is actually a very simple workbench, and it shows that sometimes even someone who thinks they know enough about FME can learn a new trick. Okay, and how this works is, and what I'm going to do is again toggle back out to the workbench. Pardon my swooping here. Okay, so oops. I'm stuck. All right, I will just explain it from the PowerPoint. Yeah, I did. That's okay. All right. So, there we go. I put it back up, didn't I? All right, can you see that? So I take my geometry that I've merged from all my data sources, and I use the geometry extractor. What this does is it takes geometry and turns it into one of the web formats right here. GML, KML, Geo JSON. Okay, so it takes, you know, the first thing I'm scratching my head, it's like, how do I go from a shape to Geo JSON? There's got to be a tool to do that because I don't want to write Python. So this is the tool that does that. Then they use the JSON templater. Okay, and all this does is it takes a framework of JSON and allows you to supply the appropriate headers, but then the body, which is what you submit in the API call, is the framework for the JSON. So when I toggled that in Notepad++, you saw this, but now you see all of these FME get attribute or FME get where is it down here? There's coordinates somewhere here, data vals. Yeah, get attribute geometry, okay? So you can read the JSON and you can then have it get the attributes and spit out the information too. Okay, so you can have a structure for JSON, you can read whatever FME gives it and then pull the informations out one feature at a time and then load it here. So the trick I learned, and I haven't found it yet, but I went and played soccer last night and drank beer with one of the developers, and I was saying what I had to do was I had to put in all of these string replacers because it was wrapping the GeoJSON with quotes. And that doesn't work because every time I then submitted it to my API, it would barf and say, not working, you've got a mismatch. And I was pulling my head out, so I just used FME to chop it, and it's ugly. And he goes, no, you can actually use the JSON templater to pull something out in JSON format. There's an additional set of functions out there. So again, had no clue, didn't know where to look for it, but they've thought about it, they've run into this, so instead of me bashing it like this, and then the JSON formatter, just run that. Don't change any parameters. You got JSON and you're about to submit it to a web API, just run it. Because what it does is it nails every single error in your JSON above and beyond. That's what was causing the errors. So I'm not writing to my web server, right? I'm not calling to my web server. And then all this is the call to the API to say, take all of this data that you've merged, that you've turned into JSON, that you've formatted properly, that you've validated, and send it up to Integra Link to be shown as a data set and a layer. See if I can get the presentation to fire up again. And that's what, this is just a sample data set of pipelines that we crammed up there. It's hyper fast, it's hyper scalable, okay? It loads really, really quickly. And this is just the process that we use to get the data up there in pipeline format. So, in recommendations to people learning FME, go take the training, okay? Don't say I'm really good and I can learn this, because when you ask Mark Stokes for help, he'll growl at you if you haven't taken the training. He gets very bent out of shape about that in a nice way. But because he said, you could have learned this in the training. So take my advice, take the time, take the training. Just the online stuff will work great because it gives you the basics, right? JSON formatter is your friend, but also is things like Postman. Postman works in Chrome and it allows you to test posting to an API. Okay, I'm not going to explain that, but it's free. It's awesome because you can take your entire API post, you know, the whole header, the whole formatter, the whole thing. Whatever text editor you want to use, Sublime is good. I like Notepad++. But these are all good tools for formatting JSON, looking at JSON, and validating JSON, right? Because don't forget, at some point, this entire workbench is fire and forget. It's going to run every time compress runs. It's going to rip all the data out of Integra Link and put all the new data in. We're not worried about tracking deltas. All right, now I have a reason to use FME server because we're just going to schedule that to respond to the event. I've just posted to default and I've compressed my database. All right, there's no event that says compress. I just run a Python string, call our catalog, tell it to do what it needs to do, and rip and replace all the Integra Link data that's been updated. Later on, we'll add more intelligence to it, but I don't have an API for that right now. I was only given these 5 APIs to use. So that's how I'm making it work. I'd like to be able to automate that process a little bit more. As the database is compressed, we run the script, but I really like to track changes. And we wrote an application that looks at the delta between 2 versions in a geodatabase. It's a C#.NET application. Runs with an interface and it runs from the command line and it's really awesome and flexible. And the day I started testing it, I think was the FME World Tour, not this year, but last year. And they said, hey, we got a version differences delta tool. So I've been really petulant and not used it for a year, but I think I need to go explore it. So just in general, APIs are really cool. You know, I think when SAFE does their API lecture, they say there's like 14,000 frameworks out there. You know, well, we've written one. And APIs are the new sort of way to do code. Instead of writing a desktop application, let's write an API for our cloud-based service. Doesn't matter what the cloud-based service is. Ours happens to be Integra Link. It's a tool that we put in front of pipeline engineers that do not give a rat's behind about knowing the names of tables in a pods or other pipeline database. They want to go to a point on the map and see everything about that point. They want to do it not only on their laptop, but on their mobile device. And the web is the way to push that information out. And they say, oh yeah, we'll write a custom script to load this. All you have to do is turn around and say, write an API. You give me an API, I can use FME to hit it. Okay, very simple workbench to grab data, to merge it, put it into JSON, other than my 3 string replacer things, which I now know how to do. That's a workbench that meets Don Murray's requirements, you know, 10 transformers or less. Right. You know, I see some people shaking their heads. But that only works because there's an API to shoot towards. And that's really the gist of the whole thing. Yes, we're doing it for pipelines. Yes, we're doing it to keep it safe. But really, we want to put data in the hands of people who need to use it and don't have to have a PhD to figure out how to do that stuff. That's it. Thanks. I think I made it under time. All right, good. Yes. 5 minutes, unless you want to, you know, skip lunch, then we could go. Go ahead.
How do you use the Integra Link? Is it just to collect on the pipeline, or is it?
There's 2 ways to do it, and I'll refrain from demoing it. I can show it on my laptop later. But there's 2 ways to do it. One is the traditional go to a point on the pipeline and click it, and then that left window will appear. So I could have data sets, but no data layer. So only something that has a data layer on it will show up. And I can choose to make data layers invisible so they don't take up, you know, typically we just show the center line, right? And here's stuff on it. That's the one. The other one is go issue an ad hoc query. Now, we do a lot of optimization on how we combine attributes to make those queries, but then you could execute, we did some work for PG&E in California, and they had a little valve site near Zinfandel. And I hated to browse to it, so I just pounded in the word Zinfandel, and that shows up, and I'm right there. So that's how that works. So.
Are you just indexing the spatial files, or is that how you provide them?
I don't know. They just gave me an API. And you know what? That's sort of nice. I just have to worry about pulling in the information and organizing it according to how the API stipulates I do it. I mean, we can link documents. We can, as long as the document resides in a URL, you know, not on a file, but in some system like Google or Dropbox, you know, and FME has a bunch of transformers for accessing that. Then you could have a feature in there. You could type in, you know, say you wanted to list all the Maximo readings for a valve. You could, as part of this API load, go query Maximo, and as long as it had that ID and you knew the valve's ID, and you type that in, it would say, here's the valve, here's where it is locationally. Oh, and here is Maximo performance data for that. So it's a really good integrative tool, but really, you know, and I know more of the guts behind it, but I really just need to know the API. That was really the purpose of the exercise. Can I put data into that? And I've really crushed them. Like, I've really come up with, well, I want to do it this way, and they're like, whoa, 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 whoa. You know, server becomes a big part because this is an individual call per feature, and that's really inefficient. It's very chatty through the web platform, but that's how FME rolls, right? Gets the feature, and it does it a feature at a time. So it's a bit of a trade-off. But yeah, both mechanisms use that. Yes, sir?
How do you monitor the compressed on default?
I write a script at 11:59 that runs the compress, and then there's another call that launches my workbenches. And it could be a little more elegant in terms of, do I need to update those workbenches? Because as I said, station series or pipeline route is a series of those 3 workbenches, and pipe segment is another 3 workbenches, and I have to do all 3 of them because that's the API. And I can merge them together. But basically, I'm automating when the compress happens. But for the record, ESRI does not expose that event. They don't expose post to default or compress, but there's other ways you can do it. If you run a compress, you can have a trigger fire from any table that you know has been edited, but then you have to have that trigger on the table. So there's a couple ways to do it. We just, 11:59:59, you know, whatever Windows proxy or whatever runs, Gmod, and it just executes compress. And then as soon as the next one is, execute FME, right? But that's a good question because we tried to get that to be event-driven because we didn't want to schedule, but scheduling is easy and cheap, so. All right, cool, thanks.